In this video, I'd like to complete several practice problems from the Chapter 3 review. In this section, we are working with compound interest equations and the compound interest formulas. So we're going to be working a lot with the formulas from earlier in this year. In this particular example, Rico deposits $800, and as we read through this, we'll see that he's depositing this just one time and walking away from it. This will be deposited in an account that earns 3.87% interest, and it's compounded quarterly. The question becomes, what is his ending balance after 1 year? Well, the supplied information, $800 represents our principal starting amount. The 3.87 is going to give us our R value, which is 0.0387. Quarterly gives us our N value, which is 4, and of course, time 1 year. Since this is a single investment, a one-time investment, we're going to use our plain compound interest formula, and we'll substitute the known values. Notice I'm using the formula in which we solve for B, our ending balance, since that's what we're after in this problem. And so at this step, we've entered our values in where they need to go for each parameter. And next, I would recommend going to the handheld calculators that we have available in our classroom. And as long as we can enter the expression into our calculator exactly how we have it written on paper, then we should be in pretty good shape. Now, I think I've done so here, so I'll press enter. And it looks like the value of the investment is going to be $831.41 after 1 year. And I'm satisfied with this result. We have computed the ending balance, and we did round to the nearest cent. In the second example, much like the first, Marie deposits $1,650 for 3 years. Now, this is not saying that she puts money into the account every year or anything like that. This is implying that it was a one-time investment left alone for 3 years at a 3% interest rate compounded daily. We need to find her ending balance. Well, we have the principal, our starting amount. We have T, our time. We have R, our rate, 0.03. The N value for daily is 365, and our goal is to calculate B. Pause the video now and set up this expression. Check your work in just a moment. And this would be an appropriate setup. Now we need to get this into the calculator. Pause the video again, enter this into your calculator, resume playback in just a moment to check your work. And since our entry in the calculator matches exactly what we had written on paper, we can trust that this result, $1,860.36, is the correct answer for this problem. Now, this example is a little bit different from those we've practiced during the start of the school year, and in this case we're actually going to compound our interest continuously. This one's going to require a slightly different formula. Balance is equal to principal times the number E raised to the power of R times T. Unlike compounding our interest at discrete intervals, we are actually compounding our interest continuously, an infinite number of times each and every year. So to handle that, we introduce this E, the natural base. It's not essential to understand why we're using the base of E. Just trust that it will be utilized for any of the continuous compound functions. And the principal and the rate and time values are much the same as what we've used in the past. I'm using P value of 1,000, an R value of 0.043, and a T value of 5. Our calculator understands what the value for E should be, So now that we have an expression written on paper, we should bring this to the calculator and evaluate the result. I'll use parentheses here to stress the multiplication at that exponent. In the calculator, you'll notice that the letter E is written as a bold letter. Now it's important to note that I did not use the letter E from the keyboard down here underneath the number pad. This letter E is not recognized as the numerical value E. Instead, to use E in an equation, we must use the E button over here to the left of base 10. So again, we're using E from this key, entered appropriately into the calculator. So I would trust that an investment, when compounded continuously of $1,000 left alone for 5 years, ends up returning the result $1,239.86. There is only one question that utilizes our continuous compound formula on the test Friday, and I think this would be a fair representation of that style of question. Moving on. Barbara would like to restore her 1966 Mustang, and she has 4 years to save for that. She invests $200 into an account every month. There's a big clue there. The account pays 4.5% interest, and it is compounded monthly. We want to know how much is in the account, or the ending balance, after the 4 years. Now the answer key says that this should be $10,496.77. Let's see if we can get there ourselves. Do keep in mind that since the investment is made every single month, and we're doing so in small quantities every month, we're going to need to use the periodic compound interest formula. And this is what that formula looks like from our formula sheet. Now we'll substitute values in place of P, R, N, and T. And if we're satisfied in doing so, then we would go to the calculator to determine the result. Keep in mind that in these examples I like to build the fraction first and then work across the numerator along the top. And then after the numerator is finished, we can move down to the denominator. Create an additional fraction in the denominator and repeat the rate, in this case 0.045, divided by 12. As you can see, the end result from our calculator does match what the predicted result from the answer key was. Our result from the calculator did need to be rounded, and that's why we'll settle on the 77 cents. In this example for Linda and Rob, it's much the same. We have an interest rate. We're compounding interest at a periodic rate. We invest money periodically. It's invested every month. And we want to know how much will be in the account, or the ending balance, after 10 years. Pause the video now, try this work on your own, and check your answer again in just a moment. Here's the setup, and here's the expression in the calculator. When I press enter, we see an end result of $173,022.87. Now I copied that answer from the calculator, and you'll notice that it didn't round when I copied. I don't anticipate the answers on the test being too difficult to identify. We won't pick two answers that are this close, one rounded correctly and one incorrectly. So as long as you've done your work correctly, you'll find a result that's very close to the correct one. In most of the examples we've seen so far, we've started with a principal amount and we've been asked to calculate how much the ending balance is going to be. But I could also ask a similar question working in reverse. How much should be invested each month in order to reach a goal? Now in the Linda and Rob example, they were close to earning $200,000 by the time the investment was done. So what we would like to know is how much they should invest per month. What's the p-value necessary so that they do reach $200,000 as their end goal? They're only putting away $1,200 right now. Could they increase that to a new number so that they reach $2,000 in that same time frame? Well, in this case, use the other form of the periodic investment formula. And this is what that formula looks like. Now we'll substitute our known values into it. And if we're satisfied with the setup, then we can bring it to the calculator and evaluate. And a quick glance at this leads me to believe that we're okay. I've got the calculator set up just the same way that we had the expression written on paper. So when I press Control Enter here, I obtain a result of $1,387.10. It's a little bit more than $1,200, but this is the number necessary in order to reach our goal of $200,000. The final questions in this group are about reconciling accounts and properly identifying an ending balance after a series of transactions. In this case, Marina and Brian have a joint checking account and they believe that their balance is $3,839.25. They believe they have this much in the account. According to the bank statement, as they look at it either online or in print view, the bank thinks that they only have $3,450 in the account. What hasn't been reported are deposits of these amounts and checks in these amounts. So our job is to reconcile the bank statement. In other words, if we start with what the bank statement believes that's in the account, add and subtract as necessary the deposits and the checks that we have listed, does the total match what Brian and Marina believe should be in the account? You should recognize that deposits will add to our account total, so we'll add our deposits, and checks will remove or subtract from our account total, so we'll subtract those values. The sum total of the balance with all deposits is $6,029.30. Now if I take the $6,029.30 and subtract all the debits, or checks in this case, then we should end up with a result that again matches their predicted balance. And indeed, the end result after subtracting is $3,839.25. This bank statement is what we would call reconciled at this point. We would use the phrase reconciled because we recognize that after the deposits and checks clear, the bank's balance of $3,450 will match our recorded balance in our check register of $3,839.25. For the final example, Jackie has a paycheck that needs to be deposited, a dividend check that needs to be deposited, a rebate check, and $130 cash to go into her account. She originally started with $278. Assuming that all the checks clear, how much is in the account after the deposit is made? Can you verify that that number should be $1,957.89? Well, after you add the checks to the initial balance, your calculator should display, yes, $1,957.89. I hope that review was helpful to you. I will be back in class, or at least I plan to be back in class tomorrow. If you have questions on this review, please let me know. Otherwise, we'll dive into Chapter 6 review tomorrow in preparation for our test on Friday.